Alright, we're still dealing with similarity or dilations. Question number 75. Is the scale factor 5/6 an enlargement or a reduction? The property we need to remember, class, is if your scale factor is less than 1, it's a reduction. If your scale factor is greater than 1, then it's an enlargement. If the scale factor is equal to 1, then we know it's neither a reduction or an enlargement. It's just equal to, why can't I write that? Sorry, ENL for enlargement. Scale factor equal to 1 is just a congruent shape. It's the exact same size and shape. So 5/6 is less than 1. If you have a hard time seeing that, just go ahead and plug that into your calculator. 5 divided by 6 equals, you can see 0.83 is less than 1. This is less than 1, and that means we know it must be a reduction. It's going to make a smaller copy, or our image is going to be smaller than our pre-image. Question 76 is very much the same, but it's asking you, is the scale factor 6/5 an enlargement or a reduction? Again, if you don't recognize that as being greater than or less than 1, plug it into your calculator. 6 divided by 5 equals, and you can see that's greater than 1. That equals 1.2. That means that the scale factor of 6/5 is actually an enlargement because it is greater than 1. Question number 77. What is the scale factor of the dilation below? Your strategy here is you got to figure out which of these shapes is the pre-image and which is the image. Once you know that, then you can figure out your scale factor. Remember, class, we learned that our pre-image, or our starting shape, is going to be labeled with regular letters for the vertices. This is the pre-image, our starting point. Labeling your vertices with prime notation means that's your image or your copy. So take a look at this. We're going from a pre-image to an image. You can see, class, that we are reducing our original shape and making a smaller shape. That means our scale factor better be less than 0. Our scale factor is going to be less than, sorry, not less than 0, less than 1. Our scale factor is going to be less than 1. Now, they don't tell us anything about the sides of the two shapes, so we can't compare corresponding sides. They don't tell us anything about the coordinates of the vertices, so we can't compare the coordinates of the vertices. In fact, we don't even know where the center of dilation is. Is it at the origin? Is it somewhere else on the grid? But we do know this. The distance from C to P prime is 5. The distance from C to P is 11. And we know our scale factor is always going to be the measure of our image divided by the measure of our pre-image. So the measure to our image, which is our copy, is C to P prime, and our measure to our pre-image is C to P. Let's plug in our values. C to P prime, the distance is 5, and C to P, to our pre-image, is 11, and that means our scale factor is 5/11. We could, of course, also write that as a ratio. Scale factor can also be written as a ratio of 5 to 11. So either one of these is a correct answer.